Hello. Today we want to talk about even, odd properties to find exact values in trigonometric functions. Now, let's look at the function of f being even if f of negative theta is equal to f of theta. For all theta in the domain of f, and the function f is odd if f of negative theta is equal to negative f of theta for all theta in the domain of f. Now, let's look at some properties here. Even and odd properties, look at this. So this basically is saying the same thing as sine negative theta is equal to negative sine theta. Cosine negative theta is equal to cosine theta. Now, this here is an even property, right? And then of course, tan negative theta is equal to negative tan theta. Now, of course, I hadn't really mentioned much, but this is an odd property and this is an odd property. This is an even property. Let me continue on real quick. You got cosecant negative theta is equal negative cosecant theta, which is also an odd property, according to a little theorem here. And the secant negative theta is equal to secant theta, which is also an even function. So we have also cotangent negative theta is equal to negative cotangent theta. So that's also an odd property. So here the only two even properties is cosine theta and secant theta. Those are your two even properties. Everything else will be odd. Now, let's look at this real quick. Let's look at the proof. Let P, some point P, on the unit circle AB corresponds to the angle theta. As you see, this is figure A, and the point Q is also on the unit circle that responds to angle negative theta. And we'll have coordinates for Q as A and negative B. Now, using the definition of trigonometric functions now, we have sine theta is equal to B, some value B. And we have, if you plug in negative theta, you get some value of negative B. Now, sine negative theta here, right, is equal to sine negative B here. So here, since this is negative B, what is B equal to in this case? Doing substitution. So we're going to take sine theta and plug it right in for B. So sine of negative theta is equal to negative sine theta. Just like we talked about over here, and also with the properties. Now, using these results for some of the fundamental identities, we have this here. If you look, tangent negative theta, tangent negative theta here. We have sine negative theta over cosine negative theta. And of course, it simplifies to negative sine theta over cosine theta, which will equal to negative tan theta. And this is going to be right here what? This is still an odd property, if you will. Cotangent negative theta is equal to 1 over tan negative theta is equal to 1 over negative tan theta. Will give you a result of negative cotangent theta. And that is also an odd property. Continuing on, secant negative theta is equal to 1 over cosine negative theta, and here we have 1 over cosine theta, which is equal to secant theta, which is your even property. Now, one more, cosecant negative theta is equal to 1 over sine negative theta, which equals to 1 over negative sine theta, which is equal to negative cosecant theta, which is an odd property as well. Let's flip back over here to the graph real quick. And as you see here, if this was, say for example, this was maybe some sine theta, some angle, and it's let's say sine 30, right? And this angle has to correspond with this angle here as well, being also negative sine 30. So you see, with this being sine 30 and this being negative sine, this in this quadrant here, as you remember, all what? All trigonometric functions are positive in the first quadrant. However, sine being positive, but in the fourth quadrant, an angle of sine 30 will also be what? This will be negative, because here in this quadrant, sine will be considered negative. So this proves this to be true also as well with the theorems, because when you plug in a positive or a negative angle, it's going to have an opposite value, if you will. With this being the original value, sine 30 being the original value, if you plug in negative 30, you're going to get a negative value, according to the graph right here, if you will. So let's go do some problems over here on the next board. So look, sine negative 45, that is. With sine 45 being the original function, right? You plug in sine negative 45 degrees, right? What would you get? You will get negative sine 45, which is equal to, the exact value would be negative square root of 2 over 2. And this is considered what? An odd function. And according to the theorem over there that we talked about, when you plug in a negative theta, you will get negative of the function, the f of theta, which is basically the negative will be right outside the function, making that sort of opposite, if you will. You may have, say again, say 45, sine 45. Let's say sine 45. Sine 45 is your original value, right? So you want to plug in negative 45. Here, you're going to get a negative sine 45 degrees, if you would. A negative sine 45. Right, you see that. So, here, let's continue on. Going to B, if you plug in now, this is sort of different. Because what? This is an even function. When you plug in, of course, the original function, cosine pi, and its exact value is negative 1. And we're going to revisit something in just a second. Let's go to cotangent, and cotangent negative 3 pi over 2 is equal to negative cotangent 3 pi over 2, which is going to also equal to 0. And this is an odd function. And then, of course, tan, being negative 37 pi over 4, is equal to negative tan 37 pi over 4. Now look at this. We have a period of pi. So here, negative tan pi over 4 plus 9 pi is equal to negative tan pi over 4 is equal to, and that exact value is going to be negative 1. Let's go and revisit something real quick. I wanted to make mention of something. Remember we talked about sine of an angle, and then because it's in a certain particular quadrant on the graph, that here is going to be opposite, right? So if it's a positive sine theta, you're going to have a negative sine theta in this quadrant. Now, let's look at cosine. Sine being an odd function, according to the theorem here, right? Let's look at the even function cosine, right? Cosine theta. If cosine theta has an angle, say cosine, let's say 30 degrees, remember all trigonometric functions are what? Positive in the first quadrant. Now, cosine positive 30 degrees, when you go down to here, right, and you have cosine negative 30 degrees, then guess what? You're still going to end up with cosine being positive, because cosine is also positive in the fourth quadrant. So this is amazing here. This is amazing, using even odd properties to find exact values of trigonometric functions. And so, if you have any questions or we'll talk about it in class, feel free to rewind the video and also take notes, take very important notes, and then continue on, and we'll talk about future instructions